Okay, just two little things I forgot to say in the last video that you didn't need to do your questions, but that I want to make sure you know. If we wanted to figure out the potential difference or the voltage across the power supply or across the resistor or across any 2 points, between any 2 points in the circuit, we would use something that's called a voltmeter. Its name kind of gives it away. It is a meter that measures the voltage or the potential difference in a circuit, and its symbol in the circuit is a circle with a capital V. So I would need to attach wires to this voltmeter and then attach one wire on one side of the resistor if I wanted to know the voltage or the potential difference across the resistor, and then the other wire on the other side. And I would get a reading of the voltage from a voltmeter. In a similar way, there is an instrument that we can measure the current that is flowing in a circuit. And that instrument is called an ammeter. No P, not an amp meter, an ammeter. Again, it measures the amps. Its symbol is a circle with an A. So it measures the amps flowing through a wire. So if I wanted to know how much current was going through this resistor, I would put my amp meter either on this side or on this side to find out. Okay, and we'll come back and talk about the placement again before the end of this unit, but I just wanted to point them out because you might see the symbols in the circuits and be wondering what they are. And speaking of symbols that you might see, in your textbook on page 701, there is a chart of symbols. Now, can I hold this and talk about them? So this is an open switch, right? So when you build a circuit like this, you always leave the switch open until someone checks it to make sure it's good, and then you close it. So if you were drawing it, this would be an open one and this would be a closed one. I will always draw it closed because what's the point of having it open? No current would flow through. So you will never see this in my drawings, but there's one in the questions in the textbook that they left it open, but you got to close it to do the question. Here's the symbol of the cell, like I showed you earlier in an earlier video. Short side's the negative, long side's the positive. This is the symbol for resistance or a resistor, and that's what we're going to talk about today. Here's our ammeter, except theirs is in pretty color. Mine was in black and white. And a voltmeter. And then the motor has a similar symbol, but with an M. Now, you won't see this in any questions that we're doing in this unit, but that's what it would look like. Here's my battery, short side, long side, and they have 3 cells together, but it could be 2, could be 4. This is the symbol for a light bulb, but any light bulbs that I will be drawing will look like a resistor because I'm not that artistically talented. Direct current generator and an alternating current generator, those are the symbols. You won't be seeing them in this unit, but there they are. And this one with the line going through it, it's a power supply, like a battery, but it's a variable one. So what that means is instead of it being, a AAA or a AA battery, it's a little thing that has a knob on it, almost like the knob on your stove, the burner on your stove. So, you could buy it at Canadian Tire and you could set it at 2 volts or 3 volts or 8 volts. Whereas the battery, the AA, is 1.5 volts. There's no varying it. And down here, the same idea as the variable power supply, a variable resistor, which means, again, it has a little knob and you can set the resistance at 20 ohms or 80 ohms or 150 ohms. Okay, so I just wanted to go through those symbols so that when you see them, you won't be, what the heck? And if you don't remember them, just come back to this page because it's in your textbook. Okay, so a minute ago I said today I wanted to talk about resistance. So we now have, let me make this a little bit smaller. We now have a current flowing in our circuit. Now, there are certain conditions, I could do it on here before I move to a new one. There are certain conditions that are necessary for current to flow. And if you look here, you can see those conditions. One is there needs to be a source that's creating a difference of potential. There needs to be a battery, a power supply. Okay, and if we were in school, we would hook up the Van de Graaff generator and you would get shocks from it. That's that big metal ball. And when you touch it, you get a shock. But then we would create a circuit with you. So the Van der Graaf generator would be the thing that's supplying the difference in potential, and you would become the material through which the charge is going to flow. And that's one of the second thing that's necessary to have current flowing in a circuit. There needs to be a material through which charge will flow. And I'll come back and talk about that in a minute. And the third thing is it needs to be a closed path. Sometimes when we did the experiment with a Van der Graaf generator, someone would get scared and they would drop their hand because they didn't want to get a shock. And then there's no longer a closed path and there's no current flowing. But as long as everyone was connected, there would be a closed path and then current would flow through. Okay, so the three conditions necessary for current to flow: closed path, so that the electrons can flow, or the charged particles, a difference in potential, usually created by a cell or a battery, and then a material through which a charge can flow. And that's what I want to talk about for a few minutes. A material through which charge can flow. Now, some materials are better at allowing charge to flow than others. The ones that are how well a material can allow a charge to flow depends on how tightly it holds its electrons. If it holds its electrons really tightly, then it's not going to be able to let charge flow through it well. If you think back to our conversation with the electroscope a video or two ago, and I talked about a sea of free electrons inside metals. They are really good materials to allow charge to flow. Materials that are really good at allowing charge to flow through them are called conductors. And metals are some of the best conductors we have. And it's because of that sea of free electrons. Right? Those electrons that are running around freely between the atoms. If you think about it, then when we go to send a whole bunch of other electrons through this metal, they're not even going to notice our electrons going through because there's already a whole bunch of them moving around freely. So conductors are, the best conductors are metals, and it's because they don't hold their electrons tightly. Things that are not good conductors are called insulators. Insulators are poor conductors. They do not allow, they hold their electrons tightly, and they do not allow electrons to flow through them easily. They have what we call high resistance. Right? Okay, high resistance. And what is resistance? Resistance is like the material's protest to current flowing through it. Materials protest to current flowing through it. You could think of resistance in electricity as parallel to friction in kinematics and forces, right? When you try to push a box across the surface, friction is like the surface's protest to the box trying to move through it. So when you're trying to put current through a wire, then resistance is the wire's protest. Every object, every material has some resistance. No matter how good of a conductor it is, it still has some resistance in it. There's actually tons of money spent by big companies trying to make the best conductors possible, because the better your conductor, then the less energy you lose to what would be considered useless means. Like, just like you're losing energy to friction, you're going to be losing energy to resistance. And it really is lost. It's not turned into anything useful. Okay? The resistance is really what determines then, if you have a set voltage, the resistance of the object then will be what actually determines how much current's going to flow through the object. Right? So we'll come back and talk about resistance in a wire. Oops, I'm going to run out of time, so I guess we'll come back and talk about everything soon.